Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 466. In this episode, Scott talks with Bertrand Le Roy about Enclosures for your DIY hardware projects.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and it's Makers Month. March is for makers. This is episode 2 in our month-long collaboration with Code Newbie, so make sure that you also check out the Code Newbie podcast. We're going to spend the entire month of March talking about hardware and the joy of making, and today I've got a hardware expert and also my friend Bertrand Le Roy. How are you?
I'm very good, thank you.
You actually had a hardware company for a while.
Yeah, I did.
You made all sorts of fun stuff. My kids built your kit. It was a little Tetris kit.
Uh-huh. Well, yeah, you could... Did you make a Tetris game, actually?
We made a Tetris game, and we made a space game. It had it was so fun because it had 2 little joysticks, but the screen was so tiny. How big was that screen?
8 by 8 pixels. It was called the Pix 64 because it had 64 pixels. And, constraints are drivers for creativity. That was the idea behind the kit. We wanted something that people could build and understand end to end. And, that had, sufficient, resources to actually make fun games, but barely that, not more than that. And, it had lots of constraints, including the screen size, and constraints, I think, drive creativity. So you have to be creative to take existing games and make them fit on such a small screen. We had a Pong game. We had, a few games like that. And, it's interesting what you can do to take a gameplay and make it work on something so constrained.
Yeah, it was very, very tiny. Our little Tetris game, I have to find the code and give it to you. But
I'd love to see that.
We never got the rotation to work. It's basically just falling shapes. So It's not very, it's just goofing around. But like you say, it's only 8 by 8 pixels. But it was a lot easier for the children to understand than, even a touch screen for an Arduino might have several thousand or 100,000 pixels.
Yes.
So speaking of constraints, one of the things I wanted to talk to you about was this idea of enclosures, because I think that they build stuff and then they end up putting it in a cardboard box, or they just cover
or
it in
Tupperware, or even sometimes they do nothing and they just leave it exposed. And
it might not sound like a glamorous topic, but it's actually there's a whole science to this.
You can get obsessed with that stuff. Actually, it's it looks like something that wouldn't be very interesting, but it's actually a very rich subject. So there are many, there's a whole spectrum of enclosures. So you can start, as you said, from, kind of ghetto enclosures using Tupperware or cardboard or Legos. Actually, I like Legos for personal projects. And, then you can try to laser cut enclosures, and then you can 3D print them. Or you can do injection molding if you're a professional and need to get a product to market.
So if people are listening and they might be picking up a Raspberry Pi, or they've bought an Arduino, they've got Legos around. Legos are good for enclosures because why? Because they're not going to conduct electricity?
Well, they're not going to conduct electricity. You might have some problems with static buildup with them, like with any kind of plastic that is not anti-static actually. But that's usually not a problem for personal projects that you don't take around much. But Lego are nice because they are very adaptable. You can create holes in your enclosures to pass wires. You can make them exactly the size you want. You can make them fit. It's almost, when you look at a Raspberry Pi, it's almost as if the Raspberry Pi was made to be enclosed in Legos. The dimensions work very well.
It definitely feels like that.
Yeah.
It definitely feels like that. There's something about the Raspberry Pi and also the Arduino. They're just kind of the perfect size. They're not too threatening that you could just cover them in Legos and put them around.
Yeah, and what's ironic is that it's actually quite difficult to make professional enclosures for the Raspberry Pi.
Why is that?
Because the screw holes are badly positioned. If you look at a Raspberry Pi 2 or Raspberry Pi B+, for example, you can see that there are two holes that are very close to the GPIO connector.
They are very close. They're actually butted up right against it.
Exactly. So try to put a cable on that. Once you have used those holes.
So certainly the Raspberry Pi is something that's optimized for kids and for fun, but not necessarily optimized for an enclosure and then a permanent installation.
It should be, but it isn't.
Well, it has multiple masters it has to serve.
Yeah, absolutely. Well, there are actually quite a few people who are creating professionally built products that they are selling that include a Raspberry Pi, and so much so that the Raspberry Pi Foundation came up with a special format of the Raspberry Pi that is made to be included in larger products.
Interesting. I didn't actually know that. We're going to have the director of development from Raspberry Pi on later this month, so I'm going to have to ask him about that.
It's called the Compute Module.
Mm-hmm. Oh, okay. So this is not, I thought the compute module was an add-on to the Raspberry Pi.
No, it's not an add-on. It is a Raspberry Pi, but it doesn't have all the connectors. The idea is that it's a DIMM format. So you include it in a product. You create your own board around it that has the connectors that you want. So for example, if you need 2 camera connectors, you can actually do it. Or if you don't need networking, you can do without it. You can put as many USB ports as you want, and so on.
I guess that when you're making a product for production, that is what you need to do. And you have to forgive me because I'm speaking from a place of ignorance, but you wouldn't just go and buy 1,000 Raspberry Pis and then build a product around it.
Many people do that.
Prototype.
Actually.
So you can do that? Like when is it appropriate to do that versus what you just described, which is build up your own custom thing based around the components of the Raspberry Pi?
Well, I would say it's mainly a question of cost. And, there are many hardware companies that actually, they're startups. And they don't start with a lot of money necessarily. And they start with a prototype, and the prototype actually becomes the product. And, that's fine to a point. It's kind of a dangerous thing to do because, you might not necessarily be able to get all the Raspberry Pis that you need. So, after a point, you should probably design your own board. And that's actually not that complicated, but, it takes time and money. So, you can save a lot of time and money by including a ready-made, Linux board such as a Raspberry Pi or a BeagleBone or.
Do you think a lot of people will spend a lot of time thinking about the software of their project, thinking about the hardware and building boards, and then the enclosure is just kind of an afterthought?
Unfortunately, yeah. But for any product that goes beyond the prototyping phase and that has to go onto the market, you will have to deal with that. And it's going to be a significant cost that you need to take into account, and you need to understand how to scale that. So different kinds of enclosures scale differently. For example, you might 3D print something for your prototype, but 3D printing won't do for industrialized production. You will need to switch to something else that is faster and cheaper to produce. Yeah, as you know, 3D printing is slow.
Yeah, I actually thought about if I were going to start a small business, I was ignorantly thinking maybe I just get a whole array of 3D printers. But, honestly, they're not reliable enough. I can't guarantee every print will work. At some point you graduate, I think, to injection molding.
Yeah. Yeah, that's the idea. Those two technologies are a nice progression because they are both 3D. So you make your 3D model for the 3D printing, and then you can probably take that same model with few modifications to injection molding, if you designed it correctly, because there are some constraints in injection molding that you don't have with 3D printing. For example, you can create parts with a 3D printer that are literally impossible to produce with injection molding because you need to remove the part from the mold once it's been injected. And that's not always possible if you don't design it the right way. But overall, if you follow a few simple rules, if you understand injection molding, you can probably take your same design from 3D printing to injection without too many problems. So it's a good progression. In my company, we've done a lot of laser cut enclosures using acrylic. And that's kind of a nice middle ground between the two because the prototyping is very fast, and you can do industrial production of laser cut enclosures. So you don't get the same cost benefits as injection, but the price to entry is a lot smaller. It doesn't cost more, to go from the prototype to the production with laser cutting, like it does with injection. With injection, you're looking at something like $10,000 to get started.
But I want people who are listening to and are thinking about spending, March making stuff to feel empowered. Like the distance between zero and a 3D printer is about $500 or $600. I know that there are home injection molding machines. I know like injectionmolder.net has kind of a portable injection molder that's, no larger than a 3D printer. You can't do big stuff, but it's certainly a very passable machine. Is injection molding really out of the scope of a hobbyist?
That's a really good point. I think that it is. It's probably for a hobbyist, it's probably a better usage of your money and time to invest into 3D printing. Mm-hmm. Because it's more adapted, to unique models and that sort of thing. But I certainly wouldn't invest in an injection molding machine as a hobbyist. But there are other solutions. You actually don't have to invest in anything. There are companies such as Ponoco that are specialized in 3D printing and laser cutting your models. So you actually just upload your designs to their website, and about a week and a half later, you receive your prototype in the mail.
So that website that you just said is Ponoco, Ponoko.
Yeah. And actually, we've used them to actually produce some of our designs. So they can do prototyping, and they can do industrial production. So it's a really nice way for a hobbyist to get started and even go much further than that. So, that's a really great solution. You don't have to invest in your own machine. It does increase the time that it takes you to create your prototype because, you need to wait for it to, come back from production in the mail, but it's fantastic.
Well, websites like Ponoco and like Shapeways will say that they'll do, same day shipping, and they can turn your stuff around in a week. So it's certainly not a day, but it's not 6 to 8 weeks.
Yeah, and they usually have some options to expedite production if you need to.
Mm-hmm. So then for people who are going to think about doing this for themselves or their kids and building something, an enclosure around what they're doing, they can start by 3D printing. they could then take that same 3D model and then do they have to modify that for something like injection molding or laser cutting? Are you moving from format to format?
So for injection molding, usually you'll have to work with the company that is going to do the production. So you work with them to adapt the design and make it work. And going from 3D printing to injection molding is going to be possible. Mm-hmm. Going from 3D printing to laser cutting, that won't work because essentially one is 3D, the other is 2D. Mm-hmm. So the designs are completely different. It just won't work.
So you might have some vectors that are like the source of like maybe a layout or a logo, but this is not simply a format change.
Yeah. No, it won't be. You're right. You'll be able to transpose the holes for the screws and for the USBs and so on that you have on your board. That will work. You will be able to save some time there, but you will have to completely redo the design in 2D basically, so that it can be, laser cutting is basically, just cutting into a sheet of material, whether it's acrylic or cardboard or leather or whatever, even metal in some cases. So yeah, it's essentially 2D. So you need to come up with a design that creates a 3D object from 2D cuts. And some of the techniques that you use are actually close to woodworking. You have joints, you have ways to make it assemble well, and so on.
Hey, this is Scott. I like a good community edition. The best things in life are free, and the community license from our sponsor, Sync Fusion, will give individual and small business developers access to more than 650 components across 12 platforms, and that includes WPF and Windows Forms, JavaScript, Xamarin, LightSwitch. You can check it all out at syncfusion.com/Hanselman to claim your free license. So, if I understand correctly then, 3D printing, which I'm now an expert at, in case you didn't hear.
Yeah, I've seen your post actually all around the place. I mean, it's been on Hacker Day, it's been on Make, and so on. Congratulations on that. Very.
Well, I'm an expert because I've been doing it for 3 weeks. The thing that's so fun about it is that, even the experts are very, very kind and very, and they're all learning as well. I was actually at Fry's Electronics yesterday, and I bumped into a guy who is an actual expert, and we had a whole chat, and we each learned something from each other because everyone's experience is different. But 3D printing is additive creation. You're taking nothing and you're adding plastic to it. And then injection molding is actually kind of like extruding and squeezing into a space, into a mold. Mm-hmm. But then laser cutting is subtractive, and you're taking two-dimensional sheets. Yes. And subtracting from those, and then assembling the sheets into your case. Yeah.
Yeah, and there are actually other techniques that we could talk about. There is actual extrusion that is used in some industrial enclosures, where that's actually a 2D shape that is, extruded. I don't know how to express it otherwise. I mean, that 2D shape becomes, it's like when you do pasta, you make it go through a hole that is a certain shape, and then you get, something long, with that shape on each end. So you can do that with metal and create enclosures like that.
I've seen people do extruded aluminum.
Yes.
And again, these are all things that I thought were kind of not something I could do as a maker. But apparently these what they're called metric profiles or Holly tube profiles are different kinds of extruded aluminum. And you don't do the extrusion yourself. No. You just buy these pieces. It's almost like PVC pipe, those plastic pipes, but they're more sturdy and they're made in aluminum and they're quite lightweight. Yes. And for larger projects, it's really quite reasonable. It's a very viable, and actually, if you're a hobbyist, you should consider using, ready-made enclosures if the format, works for you. And one thing you can do is take one of those enclosures and drill your own holes through it for your screws, for your, ports and so on that you need.
to get out of the enclosure. That's a very reasonable solution that you should consider. The difficulty is to do those holes in a way that is not too dirty and that looks good in the end. But yeah, absolutely.
Do you have to have like washers? This might be, again, I apologize for my ignorance, but how careful do you have to be? Like if I take a bunch of metal screws and plug a Raspberry Pi board or some board that I've created into a metal enclosure, what do I have to think about as far as arcing and
That's a really good question. When you're building enclosures, the fasteners are super important. They contribute not just to the quality of the build, they also contribute to the look of it. The colors of the screws, for example, can be important to how your project looks in the end. But essentially you'll have to be careful about the threads and the diameters of your fasteners so that they fit into your boards and they don't damage them and they don't get in contact with some of the components. So that's also when you do your board design. If you do a custom board, you need to make sure that your components are not too close to the fastener holes and so on. So there are lots of constraints like that you learn as you do stuff.
How will you say that you learn when you do stuff? I assume that when it bursts into flames, that's my first tip that I should
the gray smoke is something that that smell.
Do I have to watch out
for smell?
That? like for example, I'm working with my 7-year-old on my Raspberry Pi stuff. All I know is to, keep metal away from metal. But if I, for example, have my Raspberry Pi sitting in a Tupperware container or a cardboard box, do I have to worry about that? Do I have to have it floating?
You need to be careful about static discharge, whenever you handle electronics. So it's not just metal against metal. Even when there is no, electricity going through the board, you have electrons, on your fingertips. And if you touch the board, and you didn't properly, ground yourself or touch something that was grounded before you manipulate it, there is quite a high risk that at some point you will fry a board or part of a board by just touching it. So you need to be...
Do you think that people get lucky a lot? Like I feel like I don't have a static, I should probably get one of those static mats. I mean, I probably am just wandering around life getting lucky, not frying boards. And one of these days, I'm going to get nailed.
Definitely. You will. It will happen.
That's a really important reminder because I'm imagining my 7-year-old with his socks just walking in and then touching the Raspberry Pi and it's just going to stop working one day and it's dead.
Yeah. And I see that you have carpet in your office.
Indeed, I do.
So that's one more reason why you should be careful about that.
So do you think that every maker, when they're starting out, like we get our soldering gun and we put together our make space, but I don't see a lot of static mats. Is that a necessity?
Well, yeah. What you should have is a static bracelet, that you ground.
Oh, wow.
We've manipulated a lot of, electronic components, in our business. So, the person who did the packaging, for example, had to wear a static, bracelet, when manipulating certain components. Actually, she didn't like it very much, but you don't want to ship product that is fried before people get to use them.
But you make a really good point. Like you're basically, as long as you're aware that you're taking a risk every time you pick something up. Like here I am right now, I'm moving this Arduino over to the side, but I don't know what my current static charge is. So that's an important reminder when thinking about enclosures of any kind. So injection molding, 3D printing, laser cutting, all of these things I don't have to have at home. And even CNC. What's CNC?
So CNC, you said that 3D printing was additive. CNC is subtractive, in kind of the same way. CNC is actually people who started building 3D printers, often used, CNCinery to build them. They are basically setups.
What does CNC stand for?
I know that.
You know that?
I do. Yeah, you do put me on the spot. Look it up.
Of course. Computer numerical control.
Yes.
It just means moving a robot's arm.
Pretty much. So usually you have two coordinates on which something can move. So you have a device that can move in two directions and drill holes vertically. That's pretty much the idea. So there are two axes on which the machine can move, and then a third Z-axis where it can go up and down. So it's very close. It's very similar to what a 3D printer is doing, except that it's removing material usually instead of adding it. It's also how a laser printer works, except that it doesn't really move up and down, but it's the same kind of mechanism. So a plasma cutter would be the same as well.
You know, one of the things that I think is so important for people to understand, and I hope I get this across and that you agree with me, is that, you know, when I talk to like kids in school and we talk about, you know, they take things like DVDs and Blu-rays for granted. They're like, yeah, these are just things that exist, but they don't realize that it's a spinning disc with information on it and a head moving in and out radially. That's the same thing as a 150-year-old phonograph. And CNCs, engraving machines, laser cutters, these are all kinds of robots, and they basically move in three axes.
Yeah, it's stepper motors and, you know, that sort of thing.
Yeah, but if you can learn those things and understand the basics, you can do some pretty amazing stuff.
Absolutely. And there is a lot of free use that's being done. I mean, all those machines are not, you know, they are very complex, but they are made of simple components.
Exactly. I saw a what's called a Blackfoot 4-foot by 8-foot CNC router. And basically this is a cutting machine that, you know, someone, maybe not a hobbyist, but certainly a small business or an enthusiast could have. And that would cut full sheets of wood. You could build some really sophisticated, really large stuff. I've even seen them vertically oriented.
Yeah, it's a lot of fun. There are actually CNC-like machines that go in 3D, where the drill can actually move not just in the 3 dimensions, but also it's like a 6-axis machine where it can actually orient the drill to go and drill holes in funny directions. Those are really fascinating machines. There, as I said, there is a whole spectrum of technology that you can use there, and all of them are interesting to look at and understand.
Now, you had a company, but I'm curious, how much stuff did you have like on hand in your office, and how much did you go to a maker space or a hacker space and use other people's machines? Because I think it's important for people to know that these machines are available to rent, to use at local make spaces. Yeah,
that's a really good point. I don't have a laser cutter at home, and my job was to design laser cut enclosures for a few years. So exactly, you can outsource that cost very easily. But on the other hand, there are very affordable machines that exist, such as the 3D printer that you have. And there is another interesting possibility. If you're enthusiastic about making stuff, you can actually build your own machines. There are people who build their own 3D printers, and there are people who build their own laser cutters and even pick and place machines. So if you have time on your hands and passion, there is a lot that you can do yourself, and it's a lot of fun to build like that. So
now you just threw out a term that people may not be familiar with, the concept of a pick and place machine, or a P&P. And these are robots that basically pick up surface mounted chips and lay them down on a board. So if you're starting to build, your own assembly line, you could make your own robot assembly line using the same XYZ type stepper motor technology that these other things use.
Yeah, so these machines are what's being used industrially to construct all the electronics that you use. They are basically the same machinery as a laser cutter or a CNC. So you have two axes on which the robot arm moves, and then it can go up and down. And instead of having a laser head or a plasma cutting head or a drill, it has a vacuum. Mm-hmm. So it actually goes down, picks a component, it sucks, actually literally sucks a component onto the head, and then takes it where it needs to be positioned and drops it on the solder paste. So that it can be soldered in place. So it's again essentially the machine with a different head.
Yeah, they're up on the Hackaday website at hackaday.io, and keep in mind that all of these links I'm collecting and we're going to put in the show notes. But up on Hackaday, you can actually have a combination 3D printer / pick and place machine. So
yeah, and that's why it's because it's the same basis.
Exactly. X, Y, and Z, being able to move that stuff around. So it seems to me like as a parent, I would encourage people to take their kids to wherever your local hacker space is. They have places called Fab Lab or Tech Shop. Some of them are for profit, some of them aren't. But you won't know that they exist until you go looking for them.
Yeah, absolutely. There are lots of those, especially in Northern America. I don't think there is a place you can be where you don't have a makerspace available within a 50-kilometer radius, or should I say 50 mile.
Yeah, absolutely. They're very, very popular now in Northern Europe as well. So yeah. Chances are somewhere near you there is a place where you can do these kinds of things.
Yeah, and you'll find not just machines, you'll find friendly people who want to help you and teach you stuff. There are courses that you can have there. Definitely encourage people to go to makerspaces.
It feels like it's a new kind of, do-it-yourself renaissance. Everyone is just so excited. Everything came together. All these technologies of the last 50 years came together and then became under $1,000, became available to the people, all kind of within a 10-year period. And now everyone's excited about making things on their own.
Yeah. And on the other hand, you see places like Radio Shack actually going bankrupt. So.
And I feel like Radio Shack wouldn't have gone bankrupt if they'd really embraced the maker concept.
Maybe.
I don't know, maybe. Because for example, Home Depot is fine. They're healthy. And they have classes where I can bring my kids in and, build a bird bath or whatever. Yeah. But Radio Shack didn't have classes. Where were the weekend Arduino hackathons at Radio Shack? Maybe that would have kept them alive.
Yeah, or, becoming something like a makerspace, maybe, where people can take their designs and get a 3D print made or laser cut something. Or
they had the infrastructure. They could have been the place you go for 3D printing, but it would have required a level of vision it appears they didn't have.
Yeah, apparently they preferred selling cell phones and stuff like that.
Such a shame. I really do mourn them, but at the same time, I've said on other shows before, I mourn them, but not enough to pick their body and pick the pieces off, because I went over there and spent like $100 and I got $500 worth of clearance Arduino equipment. So
good for you.
I'm sad, but I picked it off their carcass. Well, thank you so much, Bertrand, for sharing your knowledge with us today.
Well, thanks for having me. Always fun to be on the show.
This has been another episode of Hansel Minutes, and we'll see you again next week.